Let's learn another technique called binary search. So we'll see very easy problem based on this technique. So from the LeetCode, this is the easy problem, binary search, and let's see this problem first. Let's see examples, and then we'll think how to solve this. So this is the searching technique. So it's saying given an array of integers num, which is sorted in ascending order, and an integer target, write a function to search target in nums. If the target exists, then return its index, otherwise return -1. So the few things are given here. So you can see here, first thing, it's a sorted. So the input is sorted, and another point is it's in ascending order, and if you do not find 9, then we can return -1. So we know, the searching technique, like if you use any searching technique, or let's say we can search in a one by one, like the brute force, then it can be either log n or n square. But here it's asking one more thing, like you must write an algorithm with O log n runtime complexity. So the binary search is always O log n. So we'll see the problem here, and I'll just write the answer for this. So the solution will be, if you search this 9, then we'll find the middle point first in this array, and then from the middle point we check whether, like, let's say the 5 is middle point, then we'll check with the 9 if the target matches with this middle point. If matches, then return the index. But in this case, the 5 is not equal to 9. So in that case, we can calculate the middle point once again. So our beginning, the pointer will move here, and again we'll calculate again the middle point, and we'll search only in this section. So every time we use some logic in such a way that either we search in right half or search in left half, and in that way we write the logic in this way. The iteration will be only in a half of this array, and again if you do not find our target, again we'll check, we'll find the middle point, and we'll see whether item is in left portion or right portion. So let's understand with this example and also write the code here. Okay, so first we fix two pointer. So first is the b for beginning pointer, and I'm saying it's 0, so I'll fix it 0, and end pointer is length of this -1, so length of nums -1, so that's the end. So we fix one pointer in the beginning here, and another pointer at end, and then we check the logic for it's a beginning less than equal to end, and now we calculate the middle point. So the logic we can write, so beginning plus end minus beginning divided by 2. So that's a middle point. So let's calculate the middle point in this case. So here middle point will be, the beginning is 0, so 0 plus end end is 1 2 3 4 5 6 minus 1, so that's a 5. And the logic is end minus b, so end is 5 and beginning is 0, so that's 0. Divide by 2. So in this case, our answer or middle point is, so 5 divided by 2, it's 2 plus 0, it's a 2. Okay, so we'll check, this is the middle point, so we'll check our target is at middle point or not. So we'll have the logic here. If target equal to nums and then middle point, if it is in that place, then we can return the middle point, that's the index. So in this case 2, so 0 1 2, so this is the middle point, and in this middle point we're checking if our target that is 9, so 9 is here or not. So it's not there, so of course it's not there. Then we'll implement another logic and we'll see that if the target is less than, you can check else. If target is less than middle point, so that's a nums b. So if the target is, this is the middle point, and if the target, that's a 9, if it is less than 3, so this is not the case, but in case if it is less than 3, then we'll search in this section, and in order to search in this section, we'll make the middle point this one, or we'll make this end point. So we'll say that, okay, begin will be as it is, but end will be middle minus 1, because we know that our target will be in this section. So that's why I can give here end equal to middle minus 1. Else if target is greater than nums b, if the target, that is a 9, and our middle point is 3, so the target is, target 9 is greater than this middle point here, then in that case we can make this 5 as a beginning. So in order to do that, I can say beginning equal to middle plus 1. So now in next case, the 5 will be middle point. So from here again we'll start searching. So the for loop closes here, and if you do not find anything, return -1. Okay, so in this case, let's try where the middle point goes. So okay, so middle point is 3 now, and then we do not see our target in this middle point. Then it will come to this section, target greater than nums b. Of course 9 is greater than nums, this is not nums b, but we can say the middle point, from the middle point nums m. So target is greater than that, then our beginning will be middle plus 1. So in this case beginning will be, middle was 2, so 2 plus 1 is 3. So beginning is 3 and end is, it's a 5. And again we'll calculate another middle point based on this formula. So beginning, so n equal to beginning is, we have the new beginning, so it's a 3 plus 5 minus 3 divided by 2. So we're calculating the middle point, so it's a 3 plus 5 minus 3, 2 divided by 2, so 1. So this time middle point is 4. So we'll check 0 1 2 3 4, middle point 4, and in this case the condition satisfies, and we can return the index, and that will be the answer. Let's run it. Let's check for the syntax. Okay. Okay, accepted. Let's submit this. Okay, so accepted, so that answer is good. Let's see the same problem solution in a Java, and we have the same logic here. We have calculated middle, it's a beginning and then end, and then we calculated middle point. The formula is beginning plus end minus b divided by 2. Logic is beginning less than equal to end. We're checking, the target equal to middle point value. If you find, then we can return this m. It's a middle point, and if the target less than nums m, so in that case we'll make end new, we calculate the new end. Otherwise we'll calculate the new beginning, and we'll find the item. If we do not find the item, then we can return -1. So yeah, so that's also here. So that's all for today. Thank you.